Very good morning, my dear students. Hope you all are fine. Now, in the previous lecture, we have discussed about the detection of copper cation, ferrous cation, ferric cation, lead cation and zinc cation by using the reagent that is sodium hydroxide solution. As I already told you that whether we will use sodium hydroxide solution or we will use potassium hydroxide solution, in both the cases result will remain same. That is, the color of the precipitate will remain same, only there is a difference in the reaction. Precipitate will remain same. For example, if you will use CuSO4 plus NaOH, then also you will get CuOH twice plus Na2SO4, and if you will use CuSO4 plus KOH, in that case also you will obtain CuOH twice plus K2SO4. So the byproduct will be different, but the main product will remain same. So today I am going to discuss the cations which are left, that is also by using sodium hydroxide solution. So here also the reagent which we will use, that is sodium hydroxide. It's your choice. Suppose you will be given some practical and sodium hydroxide is not available in the lab. In place of that you can use potassium hydroxide also, because result will be obtained the same. So let's start with our next cation, that is calcium cation, Ca2 positive. To detect the presence of calcium cation in the unknown salt sample, first of all we have to prepare the aqueous solution. The solution which is made in water, that we call aqueous solution. Aqueous word is derived from a Greek word aqua, which means water. Why aqueous solution? Because if you will make the aqueous solution of the salt, you will get better result. Make the aqueous solution and then add smaller amount of either sodium hydroxide or potassium hydroxide. If chalky white precipitate will be obtained, then it confirms the presence of calcium cation, that is insoluble in excess of NaOH. So this is the observation in case of calcium cation, chalky white precipitate insoluble in excess of NaOH. Moving on to the next one, that is magnesium cation, Mg2 positive. Now magnesium cation, zinc cation, in case of magnesium hydroxide and zinc hydroxide, results are same, that is gelatinous white precipitate. Then how we will differentiate whether the salt is of zinc metal or it is of your magnesium metal? So for that, here we have to do the solubility test. If you have taken, suppose two salts will be given to you, both are white in color, and you have to tell which one is a magnesium salt and which one is a zinc salt. What you will do? First of all, you will prepare the aqueous solution of both the salt separately in test tube and add desirable amount of sodium hydroxide. In both the cases, you will obtain gelatinous white precipitate, gel-like appearance. Then your question will be that if in both the cases it's gelatinous white precipitate, then how we will differentiate? Because results are same. For that, you have to add excess of sodium hydroxide or any other reagent which will be given to test the cation. Magnesium hydroxide precipitate will not get dissolved in excess of NaOH, whereas zinc hydroxide precipitate will get dissolved in excess of NaOH. So this is how you can differentiate between magnesium salt and zinc salt. Although preliminary result is same, that is gelatinous white precipitate, but on addition of the reagent you will find precipitate of zinc hydroxide will get dissolved, whereas precipitate of magnesium hydroxide will not get dissolved, because zinc metal, oxide of zinc, hydroxide of zinc shows amphoteric behavior which is not shown by magnesium. Why? Because magnesium is more reactive than zinc. This is the reason. Now coming to the next cation, you can see I have written NH4 positive. This is a complex cation. Complex cations are those where more than one element is present. And moreover, in this cation, we are having non-metals. It's nitrogen and hydrogen. In other that we have done, that are metallic cations, copper cation, ferrous, ferric, plumbous, that is Pb2 positive, your zinc Zn2 positive, but in this case it is complex cation. NH4 positive with non-metal nitrogen and hydrogen. Now in this case we cannot find out the cation with the help of the precipitate. Here we can find out by the evolution of the gas. So we have to take the sample in the test tube, which is to be tested, in which we have to test whether this NH4 positive cation is there or not. And then we have to add NaOH. Precipitate will not be formed, but what you will obtain, you can also heat that mixture. A pungent smelling gas will release. And how will you detect that pungent smelling gas is ammonia? Because this cation will be detected by the evolution of ammonia gas. For that, you have to take a glass rod, dip that glass rod in HCl, bring near the mouth of the test tube. It will give a dense white fume. So that pungent smelling gas, which will give a dense white fume with the glass rod dipped in HCl, will confirm that in that particular salt this ammonium cation is present. So this is how we can find out different metallic or complex cation in the various unknown salt sample. Let me revise all these things once again, which we have discussed today. For calcium, chalky white precipitate, insoluble in excess of NaOH. For magnesium and zinc, for both, gelatinous white precipitate, but magnesium hydroxide insoluble in excess of NaOH or KOH, but zinc hydroxide soluble in excess of NaOH or KOH. And for ammonium, NH4 positive, releasing of ammonia gas, pungent smelling gas, the only basic gas which turns red litmus to blue, and the confirmatory test which will give dense white fumes with the glass rod dipped in HCl will confirm the presence of ammonium cation in the unknown salt sample. So revise all these things, and in next lecture we will discuss how we can find out the cation by using ammonium hydroxide solution, ammonia solution, that is NH4OH. Stay home, stay safe. Thank you.